All right, hi. Daniel and I are going to present a new workflow engine today. So not a differentiator, sorry, but still hopefully interesting. And to give you some background, Camunda, we have a product which is called our current existing product, Camunda BPM. It's an open source platform for process automation supporting BPMN, CMN, and DMN. We launched it 4 years ago. We are quite successful, so good number of customers, 80% revenue growth last year. So we're kind of going hockey stick here. And as a fun fact, we don't have any BPM hype topics in our products. We don't have ACM or low code or RPA or blockchain, or we don't even have a full field implementation. So I'm very sorry about that. Still, we're quite successful, and the question is why. And the reason is because we totally focused on the core value of workflow as a technical concept. So those 4 elements, and the 4 specifically when it comes to BPMN, is what's driving our success, basically. And this is also true when it comes to performance and scalability. So as far as we know, we are kind of leading the pack of current existing BPM technologies in this regard as well. So this is great, basically. However, the problem is, also for us, this is not enough. So when you start talking to Google, for example, and other customers who have certain use cases, they simply tell you, sorry man, but this is way below what we actually need in terms of performance and scalability. So there are simple use cases, like for example in the telco industry when it comes to approving calls, which happen like hundreds of millions of times per minute, basically. Where current existing technologies, including anyone in this room, are simply totally not able to support this. Just one more example, Netflix have just created their own BPM technology, not even calling it BPM, for orchestrating microservices, because what is there in the industry is not enough. So we as an industry basically fail to deliver when it comes to this kind of requirements for workflow. And it's not just about load and volume, it's also about resilience, like high availability. And it's about distribution. I just mentioned microservices, but also global distribution of those services. It's about persistence, like NoSQL databases. So if you think about it, you really see the pattern. If the world is being digitalized and it's all about big data, what about all the transactions that create and consume those data? Those are workflows. So if there's big data, there's also big workflow. And this is our bet as Camunda, as a vendor. We won't do RPA or any stuff like that. So we are sure that for the next, not 1 or 2 years, but 5 to 10 years, the real thing for BPM technology is what we call big workflow.
So last year we started work on a new project. It's called TNGP, with the ambition to create the first of its kind big workflow system. It was a start from scratch, completely new code base, big investment. But the results are worth it. So already today, with TNGP, we can do more than 100 times the throughput on a single machine than what we can do with Camunda BPM. And when running this on multiple machines, it forms a peer-to-peer network. And this is a truly distributed system. So there is no master node, there is no single point of failure, and there is no central choking point. And this allows the system to scale up and down elastically. And so going from 3 nodes to 300 nodes, more nodes mean more processing power and also higher fault tolerance. And this plays well together with state-of-the-art data center and cloud management systems like Kubernetes, Docker Swarm. So with a single command, an engineer can scale the system up and down. And that only works because it's truly distributed. Jakob mentioned Netflix and microservice orchestration, which is a big problem. This system has both the processing power, but also the right interaction patterns to orchestrate hundreds of microservices. And the interaction pattern we do is publish-subscribe. So a service subscribes to a task type, and as the task of that type becomes available, the service gets notified, it can process it. And publish-subscribe gives a lot of control to the microservices. A service can choose to which task type it subscribes, it can choose when it subscribes, and it can even control the rate at which it wants to process tasks. We want to release this in July. It's going to be open source.
And now we're done.
And that's it.
Yeah. And now comes the demo. the only product probably that doesn't have any UI, so demo is kind of difficult, but you go it.
Yeah, we'll try, because this is basically technology. So we were thinking about, okay, how are we going to demo this? Yeah, the way has been paved today. I mean, we've seen some demos that didn't have UIs, we're going to build on top of that. What we're going to do first is just look at this throughput. And we're going to compare Camunda BPM, our current generation workflow engine, what we have in the market, what is currently very successful, as a representative of kind of what everybody else is doing as well. And what we're going to do is I have this very, very simple BPMN workflow. So it's first task and then a second task. And these tasks are asynchronous. And what I will do is with Camunda BPM, I will try to start as many instances of this BPMN process as possible. And then we're going to look at throughput per second. So how many instances of this BPMN process that is very, very simple can we start per second on this machine with current generation technology? So I'm taking bets here. What do you think is it going to be? On this machine, how many instances of this workflow can I start with Camunda BPM? Sorry? 10,000? Per second, yeah. How many instances can I start per second? 10,000? 400? Okay. Let's see. So what I have here is I have Camunda BPM running, and I have a Postgre database, and I'm going to start this. So and this is what we get. So like every second, it logs out the count of how many instances it has started in the last second. So, yeah.
This is for Camunda BPM?
Yes.
Not your new state?
No, this is the old kind of what everybody's doing. So I'm just going to take this to visualize it a little bit better since we have no UI. Let's put it in a spreadsheet. Spreadsheets are great. So there we go. Can everybody see this? Yeah, so you can click here. So this is the throughput per second. Now I'm going to do TNGP. For that, I need to start it. So there it is. And first, I need to create a new topic. So you can just ignore that. And now we're going to start as many instances as possible per second. Okay. So this is a little bit better. Slightly. So get it run for a second. More. Okay. Let's stop it. And let's put this also in the spreadsheet. So there we go. So, and this is the, well, this is the difference. So kind of the blue line is Camunda BPM. We can't even see it anymore with this new red line. But this is only on my computer. So this is on this machine. I can currently do 50,000 instances per second. Sometimes it's a little bit more. Sometimes it's a little bit less. But this is a new kind of dimension. So it's not twice as fast. It's not a little bit of optimization. It's not like, let's tweak some things. But this is really a new kind of dimension. So what would be interesting now is to explore a little bit, why is it so much faster? And Camunda BPM, the old process engine, is a representative of what many people call the transactional workflow engine model. And it has been around for decades. And it's a very simple model. It's a great thing. It has been very, very successful over the last decades. And I'm just going to try to show what that means. So Camunda BPM actually has a UI. That is good. So let's log in here. And this is just a very simple task list. And what we see here is that we have a task, and this is our diagram. And we're currently, this is the BPMN diagram, so we're currently waiting, we're currently waiting here in this approve invoice task. Now, let's look into this Postgres database to see what that means. So we go over here. And what we see here is just a Postgres database that's behind this workflow engine. And we see here that there is, I want to direct your attention to this column here, which is called activity ID. So this has the ID of the activity in which this workflow instance is currently waiting, which is the approve invoice activity. So now I'm going to complete this, and we're going to see what changes here. So let's go back to the task list. This is our form. Do you approve? Yes, of course. So we complete this. And let's go back to the database, and let's refresh. So maybe I'm...
First of all, demonstration.
So I got to connect again. Okay, interesting. So let's close this and connect again. Okay, there we go. And let's scroll a little bit here. So what we see now is that here there's been an update has been done. So the column now reflects the next state in the process. So the way the transactional workflow engine works is very, very simple. For each task, for each workflow instance, you have a row in the database, and that row holds the position or the ID of the task at which we are currently waiting. And whenever you go from one step to the next, you need to go to the database, you need to load this data, and then you update it to reflect that it's now waiting at the next task. Very, very simple. Now, TNGP completely goes away from this model, and I'm going to try to show that. So first, I'm going to just stop it and remove the data here and start it again so that it's empty. And I'm going to now do the following. I'm going to create this topic again. And now what I'm going to do is I'm just going to start one instance, and then we will be able to see what that means. So I'm going to start a single process instance here. Okay. Successfully created workflow. And then I'm going to go here, and I'm going to show an event log. And that is the whole point. So now, this persistence is completely different. So it does not have this relational database where we have a column in which we store the current state of the workflow instance. But instead, what we see here is an event log. And what we see is we have a first event. A deployment has been created. And then the workflow instance has been created. The start event has occurred. The sequence flow has been taken. An activity has been activated. And then the task has been created. So as this engine works completely different. As it moves through the process, it generates an event log that it both generates and consumes to drive execution forward. So if we now complete this task here, so let's just do that. So this is now completed the task. We see that some more events have been generated. So first there was a complete command, then that was executed successfully, so the task has been completed. With this, the BPMN activity has been completed, the outgoing sequence flow has been taken, the end event occurred, and the workflow instance completed. And so this is a completely different persistence model that we can process very, very efficiently, because now we can stream this through the system. So this is basically event streaming and event processing. We stream this to disk. We stream it to other nodes for replication. And streaming access patterns are always very, very fast. So SSDs can write 600 megabytes per second. Via the network, if I use it in a streaming way, I can transfer 10 gigabytes per second if I'm using a very, very fast network. So with this kind of persistence and with this kind of streaming technology, we can use hardware very, very efficiently. And when we think about what you said yesterday, that compute, storage, and network bandwidth keep getting cheaper and cheaper, we need to build technology that allows us to use that. And currently, in our industry, we're not very good at that. And we need to get better. Because if we do, then we can bring this kind of technology, so the advantages of BPMN, the visibility, the business IT alignment, we can bring that into contexts where it was never possible to use it before, like the big distributed systems with hundreds of microservices, like what Jakob was talking about, the soft real-time contexts where you need to, when a person types in a phone number, you need to approve the call. You need to do that within a second, and you need to do it at a very large scale. And that's kind of where we want to go with this kind of technology. We have a little bit more time. One thing that we can do is, just for fun, create a bunch of more instances again.
While you're doing that, can I just comment one
Yeah.
more thing? So that's why one reason why we call it BPMN to infinity. So we have this like high throughput on a single machine, but this event streaming based persistence allows us to add additional nodes of persistence as well. Let it be hard drive, let it be Cassandra, let it be you name it. And this means that we can literally scale this to infinity, like in the cloud, for example. So we can basically process any amount of transactions in a certain like short time span, thanks to this approach, which is quite important, of course.
Yeah. So now what I have here is I started a bunch more instances, and I already had one worker running to complete the first task. And yeah, well, now it's kind of deviating from what I want to have. But yeah, I shouldn't have done that, because now I have everything running. So this is kind of I know I've started many instances, I have the worker running, and this is the event stream, which is still open, that just streams out all the events that are happening. So this is doing a lot of things now, and I should probably shut it down. Yeah, but this is great. Well, we see, okay, this is what my computer is doing. In our labs, we have a test bed. So this is the computers we use to test it in our labs. This is like 5-year-old server hardware. On my computer, I could do 50,000 instances per second. There, I can do almost 100. And we are very, very confident that we can push this a lot further, because we only started out with this. And I already have like 3, 4, 5 very simple optimizations that I can do to just make this 5 times faster again. Yeah, so that's basically what we wanted to talk about with TNGP. Now, this session is named BPMN to infinity and beyond. This was infinity, and now we want to do the beyond part. The beyond part is a little bit more, it's a little bit funnier. So, and for that we need Node.js. So let's go here, and let's start with this.
And while you're doing that, let me just comment on that. So every year, you know that I love to give that bonus track about BPMN.io, our open source framework for BPMN modeling that we provide online. So you point your browser to bpmn.io to download it, BPMN.js, and you can just use it in your own application. So every year we have our hackathon, and we try to do silly stuff with BPMN. So this is one example. So we had one team that created a, how would you call it?
A synthesizer.
Yeah, exactly. So BPMN-based synthesizer, which basically brings back the original meaning of BPM, you know, like beats per minute. So, And the manual task, Cool.
Yeah, and there's more things you can do, I don't know.
Is it also open source, or is it?
This is open source, yeah, definitely.
Ah, damn it. Okay.
Okay, so this is one thing, but let's turn it down. There's more.
True, and that's like the last thing. And you know, since we use BPMN a lot, and we do a lot with BPMN, and sometimes BPMN can be really annoying, as some of you know, of course. So for all the BPMN haters out there, we have created an arcade game. So we have actually created our own, you know, little machine, and with the little plastic pistols. This is our conference. It was a huge success, really. And what we did there is using BPMN.js and yeah, use it in a fashion that really does make sense for anyone, I guess, even those who don't like BPMN. And you can also use that yourself, of course, if you need to, you know, vent, is that the right word? So to steam off, and yeah, just shoot it, you know.
This is for the BPMN haters.
So how many shots per second can you do, Daniel? Sorry? How many shots per second are you able to?
I don't know.
Okay. All right. Yeah, thank you. This is it. We're through.